indications of volume. And the first example, a cylinder of solid material with a radius of 4 inches and a height of 10 inches has a cone with the same radius and height removed from it. So key word in this is removed. What is the volume of the remaining material, and round to the nearest cubic inch? So we're going to take this and we're going to remove that part from the picture, is what we're going to do. So in other words, what we need to figure out is well, what is the volume of the cylinder, which I'm going to abbreviate as CY. And then we're going to have to figure out the volume of the cone. And again, we're removing the cone from this. So ultimately what we're going to do is we're going to subtract those two. We're going to subtract the cone from the cylinder. So we look at our green paper and we remember that the volume of a cylinder, the formula is pi r squared h. And we look at the volume of the cone and we see that our formula is 1/3 pi r squared h. And then we can figure out our volume here. And what I do, well, you'll see it, but I leave pi in the answer for now, and then I just calculate it once. So looking back over here in our figure, what we see that the radius of this is 4, and it's the same radius whether it's a cylinder or a cone. The height is also going to be the same value, but we're taking out that cone from there. So when we figure this out, we're going to put the 4 back in here. So this is pi times 4 squared times our height of 10. And when we type this into Desmos, we type it into our calculator, what we end up with is 160 pi. And again, I'll deal with the pi. It says round to the nearest cubic inch here in a couple minutes. Over here with the cone, it's not going to change that much. It's going to be 1/3 times pi times 4 squared times 10. And I might need to type this one in. One divided by 3 times 4 squared times 10. And we get 53.33. Again, it's going to say round to the nearest cubic inch. So let's just say 53. And then one more time. We're removing this cone from the cylinder. And consequently, what we're going to do is we're going to subtract those two. So we can take 160 and subtract 53 from that answer. But remember that the answer at that point would be 107 pi cubic inches. And then if we prefer it to be to the nearest cubic inch with the pi calculated in, we go back and we use our 107 times pi. Again, pi is easier to use on Desmos than it is the calculator. But we get 336 when we round that to the nearest cubic inch. Second one, interesting problem, and a popularly asked OST question. And it says a pill has the shape of a cylinder with a hemisphere at each end. Remember hemisphere being half a sphere? The height of this cylindrical portion is 12 millimeters and the overall height is 18 millimeters, and we want to find the volume of the pill. Well, first of all, what I want to take a look at here is that the half sphere on top and the half sphere on the bottom form the whole sphere. They form a sphere. So ultimately what we're going to do is we're going to take the volume of the cylinder and we're going to take the volume of the sphere, and when we want to find the overall volume, this time we're going to be adding these two together. But we need to do a little bit more intel on this problem. This portion is 12. That means, and overall this portion is 18. That means if we take 18 minus 12, we get 6. And what that means is that from here to here is going to be 3. And from, I don't know if I can draw it in down here, but if I draw it down here, from here to here, is also 3. So in other words, what happens is that the diameter of the sphere would be 6. Again, the 18 minus the 12, that gives us the rest of the height to apply to the sphere. And ultimately what that means is that the radius of our sphere is 3. So now we know what we have to do. And what we're going to do is we're going to find the volume of the cylinder. Once again, looking at our green paper, the formula is pi r squared h. And then the volume of the sphere, if we look at our green paper, is 4/3 pi r cubed. And we'll put in what we need. And overall here then, not only is the radius of the sphere 3, but the radius of the cylinder is also 3. When we calculate this out, we get pi times 3 squared times 12. Gonna leave the pi in here, so we get 3 squared times 12, which is 108. We get 108 pi. Eventually what we're going to be doing is we're going to be adding that value to the sphere, and our sphere is 4/3 times pi times our radius, which is 3 cubed. So I'm not typing in pi right now, I'll put it in the end. But it's going to be 4 divided by 3 times 3 cubed, which gives us 36 pi. And we can add these two together. So we've got 108 plus 36, and that gives us 144 pi. And when I go back and look at the directions here, round your answer to the nearest millimeter. So we really do want to put this in terms of, we really want to put this in terms of a decimal. But we've got the 144, so now we should multiply 144 times the pi, and we end up with 452.39. So we're going to leave it as 452. So we're looking at the 3 to determine what to do to that. It's going to be 452. And our units on this one are millimeters. Number 3. At a sawmill, the circumference of the base of the cone-shaped pile of sawdust is 50 feet. The cone rises at an angle of 40 degrees. Find the volume and round your answer to the nearest tenth. Again, another good OST question. And the only thing that I don't like about the question is I wish that it said the cone rises at an angle of elevation of 40 degrees. because I think the angle of elevation might tip you off that we need to go back and use our sine, cosine, or tangent problem to figure out info in this problem. We do know that the circumference of this is 50 feet. So we're going to start with that, and we've got our circumference formula on our paper. Looking at our reference paper, circumference is 2 times pi times r. And if we take this value and we put 50, and here 2 times pi times r, we want to figure out what the radius of this is. And it does say round to the nearest tenth. But what's going to happen is we're going to divide both sides by 2 pi. And what happens is that the 2's cancel out. 2 divided by 2 is 1. Pi divided by pi is 1, and we get our radius. We can type that into our calculator, and we get 50 divided by, and if you're not using a fraction button, we need parentheses around the 2 pi. So we get that value there. With the fraction button, which is alpha y equals enter, it's 50 divided by 2 pi. Still get that value. And if we're rounding to the nearest tenth, what happens is we're looking at the 5 to round to the 9th. But because that 5 is 5 or higher, that's going to round that 9 up. And ultimately, instead of 7.95, we're going to get our radius there. We have to round the 9, which causes us to round the 7, 2, and 8. So we're going to get our radiuses 8. And we can fill that in over here in the picture. It's going to be that length right there. We want to find the volume of this sawdust cone. But what we now need, because our formula is 1/3 times pi r squared h, is we need to figure out what the h is. We just figured out what the r was. We need to figure out what the h is. So we take a look at this. The h is here. And what we have is we have a right triangle. And across from the right angle is the hypotenuse. And across from the angle is the opposite, which means our radius is the adjacent. And just a reminder here, when we think back to our trig work, is that sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent equals opposite over adjacent. So as we take a look at this, we know the opposite. Well, we want to know the opposite, and we do know the adjacent. And what function has opposite and adjacent in it? Well, that's going to be the tangent. And it's tangent of 40 equals h divided by 8. And to figure out what that value for our height of our cone is, we're going to multiply this side by 8 and this side by 8. And that's what we're going to type in. But be really careful. If you're using Desmos, you have to convert it back to degrees. And in fact, on my calculator, I have to convert mine back to degrees as well. And if you're using the calculator, I'm going to clear this. We go to mode, and I need to arrow down and then make this cursor flash on the degree. So I'm going to hit enter. And then to get out of that mode, second mode, now I'm in degree. So we're going to type this in. 8 times tangent 40. 8 tangent 40. So we get the height here of 6.7. So lastly, Now we have the radius, we have the height of our cone, and we can figure out our value by using our final formula here, which is the 1/3 times the pi times the 8 squared times the 6.7. Oof. And again, our problem tells us to round to the nearest tenth, so I am going to type pi in this time. So when we go back here, 1/3, 1 divided by 3, times pi times our radius 8 times, that might be nice if I have squared on there, 8 squared times the 6.7, and we should end up with 449.03. Again, we're looking at this 3 to determine what to do to the 0. So what we need to do is we need to leave that 0 as 0. So it's 449.0. I'll look at the units here. And our units, if we've got them, are feet. At an aquarium, a shark tank is shaped like a triangular prism, as shown below. If the tank is 4/5 full, how many cubic feet of water are in the tank? So, when we take a look at this one, what we need to know, and it even tells us in the problem, that we're working with a prism. So our general prism formula, which is the area of the base, big B, times H. So we're going to start with finding the volume of the entire tank. And a reminder here is our base is the triangle. So worst comes to worst, you need to look at your formula sheet to find the area of the base for a triangle, and the formula is given to you, and that is it's 1/2 times base times height. And we look over here, and what we see is that our base of our triangle is 120 feet. Our height of our triangle is 80 feet, and we can type this into our calculator to get big B, the area of the entire base. And it's 1 divided by 2, and maybe you use 0.5, which is what I frequently use, times 120 times 80. And we get 4,800. So 4,800 feet, cubic feet, square feet for that. So we're going to take that value of 4,800, we're going to put it back into our base, and then we're going to multiply it by the height. The height of this picture is 100. Then worst comes to worst, you type that into the calculator. So we can take the 4,800 times 100, and that's going to give us the volume of 480,000. The thing is, if you've ever been to the zoo, there's usually some airspace at the top of a container like this. And what it says is, if the tank is 4/5 full, so we need to finish by taking our 480,000, and we're going to multiply it by 4/5 to find how much water is really in the tank. So again, we pull out our calculator, or we pull out Desmos. So we've got 480,000 times 4/5. Again, don't have to have that fraction button to do this. And when we finish here, we get 384,000 cubic feet of water.